Hello students, welcome to Narayan PU College online classes. So in the last video we have discussed up to the 24th question, competitive questions of haloalkanes and haloarenes. So now we will discuss remaining questions here. See the question number 25. Question number 25. Clear ma? So what the question they have given here is, if the following E2 reaction proceeds through an anti-periplanar transition state, what products are expected? Clear ma? So what they have mentioned here, if the following E2 reaction proceeds through anti-periplanar transition state, means E2 means elimination reaction. It is elimination reaction means in the last video I have already mentioned the eliminated groups should be in anti position, the leaving group and the hydrogen should be in the anti position. Clear? Then the elimination E2 reaction takes place very fast. Clear? So now they have given here the compound. So what is the compound they have given here is, this is the compound. Clear ma? So here CH3 is towards the observer, or you can say this is chlorine atom. Clear ma? So now it is CH3 is present here, it is front side, means here hydrogen one will be there. Where it is? It is on the back side. Clear ma? It is. Now so which product you will get, they are asking here. Clear? You know that in the E2 elimination the leaving group and hydrogen should be in which position? Anti position. So one is front side, means another one should be back side. See now here chlorine is back side, and here this is alpha carbon and here beta carbon and this is also beta carbon. Elimination takes place always from the beta carbon, beta hydrogen will be removed here. So in this case this hydrogen and this chlorine will be removed? No, it won't remove. Why? Because that hydrogen and chlorine are in the same plane, because chlorine is backside and hydrogen also backside the plane. Clear? So that's why both are in same plane. When both are in same plane, E2 reaction will not take place faster. So that's why. And that here which one is there? Here one hydrogen is there and also there will be another hydrogen present here. Clear ma? Then what happened? You see here hydrogen atom is there. Whenever hydrogen atom is there, chlorine atom is backside the plane and hydrogen atom is, you just assume chlorine is below the plane and hydrogen is above the plane. Both are in which position? Anti position. So that's why elimination easily takes place. So then what the product you will get? You see, you will get the product is here double bond, and here what is there ma? CH3. Then what is the product you will get? Will this hydrogen removes? No, it won't. Why? Because that chlorine and hydrogen both are in same plane, so it must be anti position. So that's why you will get only this product. What is the name of this product here? So that 1 2 3 3-methyl cyclohexane. So option 1 is the correct one. Next one. See the question number 26. Question number 26. Clear ma? See the question what they have given, and here the question is CH3, CH2, CHBr, and here there is a CH3. What they have given on the arrow is alcoholic KOH. What they have given here? Alcoholic KOH. They are asking here X, and that X must be what it is? Major product. Another one they have given here CH3, CH2, CH, nitrogen positive charge, and 3-methyl groups are present on the nitrogen, and here CH3, and now you will get the compound is sodium ethoxide. They have given on the arrow and heat it. Clear? And here what you will get? Y is the what it is here? Major product. Clear? So what is the X and what is the Y? They are asking that question. Now you see, simple, you already know this is a alkyl halide, and what they have mentioned here reagent alcoholic KOH. Whenever alcoholic KOH and alkyl halides are there, what is the reaction? You already know it is a elimination reaction. Elimination reaction follows which rule? Sage-Joff rule. According to the Sage-Joff rule, highly substituted alkenes are the major product. Clear ma? So that's why alcoholic KOH means elimination reaction takes place. Elimination reaction means you know that elimination always takes from which hydrogen? Beta hydrogen. So alpha carbon, bromine attached carbon we will call as a alpha, and this is beta and this is beta. Clear? But they are asking which one? Major product. Major product means we have two possibilities. If this beta hydrogen is removed, then H and Br will be removed here. Then alpha and beta between this carbon you will get the double bond. Elimination reaction, double single bond is converted into double bond. Then what the compound you will get? CH3 and CH double bond CH3. This is one product. Another one is what it is? Another one, what is the chance here? If this beta hydrogen is removed here, then this hydrogen and bromine will be removed. Then the double bond will form first carbon and second carbon. You will get the compound is CH3, CH2, CH double bond, CH2. Which they are asking here X, what it is? Major. We got here two products. We got how many products here? Two products. So you have to identify which one is the major product. You already know that according to the Sage-Off rule, you know the formation of alkenes follows the Sage-Off rule. According to the Sage-Off rule, highly substituted alkenes are major products. You already know that this is double bonded carbon and here one CH3 group is there, and to this double bonded carbon another CH3 group is present here. How many substituents are present here? Two. In this case you see, and hydrogen we never consider as a substituent. Here two hydrogens are there to the double bonded carbon, but we will not consider those are substituents. So that's why here to this double bonded carbon there is only one group is present. So that's why this is having only one substituent. So that's why you know that according to the Sage-Off rule, and highly substituted alkenes are the major product. So that X will be this is. Clear? And the next one, I already mentioned quaternary ammonium salt whenever treated with the base, and it will give the Hoffman product. Clear? What is the Hoffman product? According to the Hoffman reaction, means according to the Hoffman rule, you know that less substituted alkenes are the major products. Here more substituted alkenes and here less substituted. Which one here? Quaternary ammonium salt. Whenever quaternary ammonium salt and base is there, which product you have to write? Hoffman product. Hoffman product means what? Less substituted alkenes are the major product. Clear? So here Hoffman is there and here base is there. So what happened here you see? And one H, here this is a alpha and this is beta and this is beta. Clear? If hydrogen is removed from here and one H and this molecule will be removed, double bond will formed here. That is more substituted alkenes. But here in this case, and hydrogen from here, you know it is a base and it is Na plus and OE2 minus. Base what it will do? Always accept the proton, and this bond electrons are free. Bond electrons will come here. Single bond is converted into double bond, and when double bond comes here, carbon is having how many bonds here? 5 bonds, but carbon should have how many bonds? 4. So that's why this is a very good leaving group and it removes. Then what the product you will get? You will get the product is here CH3 and you will get the CH2 and CH double bond CH2, and plus another chance is what? Here also it may remove the proton, and then what the product you will get? CH3, CH double bond CH, CH3. This is which one? This is major and this is which one? This is minor. Clear? Because it is a Hoffman product. So what is your option? You see now your option is clear here. So trans, you know that here alkene is there. Alkene is there means it is a major product, but you know alkene existed in a geometrical isomers. One is a cis and another one is the trans. Which alkene is most stable? Do you already know that is first year you have already studied? Trans alkenes are more stable than the cis. So that's why this form is which one? Trans. Trans, 2-butene and another one is 1-butene. This is the question number 26. Answer is option 4 is the correct one. Clear? Next one. See the question number 27. What is the question? Consider the given reaction. They have mentioned consider the given reaction. What is the reaction here? CCH3HOTS. Clear? And here C2H5. And here what it is? C2H5. And then they have mentioned here sodium cyanide. Clear ma? Sodium cyanide. Then they have given here CH3, you know, CH2, CH3, you are getting here Cn. CH3, what it is here? Cn. Clear? This is Cn. Yeah? Which of the following statement are correct for the above reaction? Product formation, first option. Option 1 here. Product formation takes place due to breaking of the OTS. Due to breaking of OTS and product formation takes place, they have mentioned. The reaction is a SN2 reaction. The reaction is a SN1 reaction. Configuration of the product is, yes, configuration of the product is what they are asking saying here, yes. But you know the reaction, you know OTS is there. OTS means very good leaving group. Clear ma? Very good leaving group. And you know that sodium cyanide. Sodium cyanide means what it is ma? Na plus. And what you will get here? Cn minus. Clear ma? Whenever it is there OTS, very good leaving group is there, the reaction follows the SN2 mechanism and this OTS will be removed. Clear? Then what you are getting product here? You are getting the product is instead of the OTS, and what you will get here? Cn. OTS bond breaks, but it won't break here. Why won't break? If it break, you will get the which one? Carbocation. Clear? But here when it will break, due to the nucleophile attack on this carbon, then after then OTS is breaking. So first OTS is not breaking here. When first OTS breaks, then carbocation should be the intermediate. Clear? So that's why your option 2 is the correct one. Clear ma? Next one. Coming to the 28th question. SN1 and SN2 products are same. Means and SN1 and SN2 and both products should be same for this SN1 and SN2 reaction. Which compound gives, they are asking. They have given 4 compounds. Which compound gives the product or the both are same for the S1 and SN2. Clear? See the first one. What they have given here, this is the compound and here there is a Cl. Clear? So first option is this one. You know that nucleophilic substitution reaction. Nucleophilic substitution reaction means nucleophile should be first added. You know that first this chlorine will be removed, in which case SN1. Clear? Then what you will get here? Carbocation you will get. Which carbocation you will get here? And here chlorine is removed and you will get the positive charge here. Whenever there is a positive charge, means carbocation is a intermediate, there is a chance of resonance, not resonance, rearrangement. I already mentioned in the previous classes. Clear ma? Whenever there is a carbocation intermediate in the reaction, then there is a chance of rearrangement. Rearrangement means what it is ma, you see, and it is a which carbocation? It is a secondary carbocation. You already know it is a secondary carbocation. Now there is a hydrogen here. Now this hydrogen along with this bond electrons and comes here. You know that along with the bond electron means hydrogen getting which charge? Negative charge. And here which charge is there? Positive charge. Negative charge and positive charge, there will be a bond. So that's why what the compound you will get here? You will get the compound is, you know, here hydrogen will be added. Here H is removed as a H minus. Means carbon will get the which charge here? Positive charge. Clear ma? You will get the 2 products here. Whenever nucleophile removes only chlorine, you will get the OH will be here. Suppose just assume nucleophile is a OH. Then OH will be removed here. This is, I will write 2 products. One is here, directly OH is removed. Cl is removed, then OH is added. This is one nucleophilic SN1 reaction. Clear? And another one, what is the product here? When rearrangement takes place, what the product you will get? You will get the product is here hydrogen and here there will be a OH and here CH3. This is how many products you are getting here? 2 products. But you know that in this is SN1 product, but you know that in the SN2 there is no intermediate formed during the SN2 reaction. There is no intermediate, then there is no arrangement. So that's why whenever SN2 reaction takes place, only chlorine will be replaced by the nucleophile. You will get only this product. But in the SN1 reaction, you will get this product and also second product. Both products are not, you see, in the SN1 only we are getting two products, but in the SN2 only we are getting this product. So that's why both the products are not same for the SN1 and SN2. Coming to the option 2. What is the option here? And you know that this is the option 2. They have given chlorine and what it is there? Hydrogen. Clear? Now, see now, first of all, OH minus. Just assume nucleophile is a OH minus. SN1 reaction, we will take SN1 and SN2. So first I have considered here SN1. SN1 means what will happen here? First of all, carbocation is the intermediate. Chlorine will be removed. Then which one you will get here? Hydrogen, positive charge you will get. Chlorine is negative charge, carbon is positive charge. Clear ma? Now, it is a which carbocation? It is a secondary carbocation. Is there any chance of rearrangement here? No. Why? Because if hydrogen comes here, you will get the positive charge in this carbon. Then it is also which carbocation? Secondary carbocation. Whenever the hydrogen is, this hydrogen or this hydrogen involved in the rearrangement, again you are getting the secondary carbocation only. So that's why it won't involved in the rearrangement. It won't involved in the rearrangement. But here you see, it is a secondary carbocation. It is a which carbocation? It is a tertiary carbocation. So that's why it is the most stable. So that's why rearrangement has been taken place there. Clear? So here no rearrangement. So that's why only one product. That is what it is. Chlorine is substituted by OH. If I write the same thing for the, same thing for the SN2 mechanism, means OH minus. If I write the SN2 mechanism for this reaction, same OH will be replaced. Cl will be replaced by the OH here. Then what the product? Both products are same or not? Yes. So that's why your option is option 2. Next one. See the question number 29. Clear ma? What is the question here is, they have given CH3 and here there is a CH3 and here HBr and BRH is treated with zinc dust. Is treated with what it is called? Zinc dust. Clear? So this type of compounds, bromine and bromine both are in opposite direction. So these type of compounds we will called as a trio compounds. Clear? If same, suppose like this, if I write CH3 and HBr and HBr, both we are on the same side, then this is trio and this is erythro. Erythro. Yeah, this is trio compound, this is erythro compound. This is like we could not say it is a trans, but for understanding purpose I will write here it is a trans like. And here what it is here? It is a cis like, because both we are on which position? Opposite position. Opposite position means we will consider like a trans. And here bromine and bromine both are on which side? Same side. Same side means what it is? Cis. Clear? Same reaction we have discussed in the previous. Zinc is there, zinc dust and two bromine atoms are there. Which reaction it is? Elimination reaction. Z and Br2 will be removed and you will get the alkene. Means which alkene you will get? That is the question here. Clear? I already mentioned in the last video. See, this is a like trans. It is a what it is here? Trans like compound. We could not say trans, but for just understanding, it is a trans like compound. Zinc dust means it is a elimination reaction. Elimination reaction, what I mentioned here? Elimination reaction is a always anti-elimination. Anti means what it is? Trans. And you know that trans plus trans, what you will get here? Cis. Previous I already mentioned. Clear ma? Suppose they have not given this. Suppose if they give like this, 7 zinc dust if they give. Clear ma? This compound, zinc dust. You know this compound is which compound like? Cis compound. It is a cis. But elimination is a which one? Trans. Anti. Anti means we will consider as a trans. Clear ma? So cis plus here what it is? Trans. Trans means you will get here trans only. Clear? So trans plus trans, cis. And also cis plus cis, you will get the cis only. Cis plus trans or trans plus cis, you will get the trans only. Clear ma? So this is two concept. Here what you will get here? Cis only. This you have to remember. In the last class, I already mentioned this is cis plus cis, cis, trans plus trans, you will get cis, and cis plus trans or trans plus cis, you will get the trans only. Clear? No? Now it is over. Now you know that this is a which product like? It is a trans product. Clear? No? Trans reactant here. It is a trans, and zinc dust we added. Elimination. Elimination should be which one? Anti. Anti means we will consider as a trans. So that's why trans plus trans. What you have to get? Cis means whenever zinc attack here, and this bond will come and this bond will go. Clear? Ma? The formation, you know that zinc, it will reacted with the bromine. Bromine make a bond with the zinc, and this bond will be free. This bond come here and it converted into single bond is converted into double bond, and carbon will have 5 bonds here. So that's why bromine will be removed, and again zinc will react with this bromine. You will get the minus ZnBr2. Means zinc removes the 2 bromine atoms here. Clear? Ma? Then which alkene you have to get? You will get the alkene. Which alkene you have to get? Cis alkene. Cis alkene means what it is there? Ma? CH3. You know there will be a double bond and H. CH3H. Clear? And a double bond CH3 and H. Here also which one is left? CH3 and H. Both CH3 and CH3 should be on the same side. Then only we will call it as a cis, or simply I can write in this way. Clear? Ma? This is CH3, this is CH3. Both the CH3 are present on which side? Same side. So that's why it is a which product? Cis product. If suppose they ask for this, what is the reaction? What is the product if they ask? Then what we have to write? You know that it is a cis, and zinc addition means removal of Br2 means elimination reaction. Elimination reaction is which one? Anti. So cis plus, you know, trans. What you will get here? Trans product. If they ask here, you have to write this is the product. What product you will get? Ma? Trans product. Clear? But they have not asked here, and they asked only the first question. So which is the answer here? Cis, not the trans. So your option is option 2 is the correct one. Clear? Ma? Coming to the question number 30. Question number 30. Clear? So they have given here 4 compounds, 3 compounds they have given. Major products, all are A major, B major, and C also major. Total number of alpha hydrogens they are asking. Clear? Ma? See the first one. What the question they have given? This is the question. And here OH, and they have given H plus, and here heat, and you will get the product here. That product should be major product. Means major they have given means in this case we will get the 2 products, but one is the major and another one is the minor. Minor should not be considered. That is the thing here. Clear? Next one. Another one is there. This is the 5-member ring they have given. 5-member ring, and here OH. OH, and same H plus ion and heat. You will get the B here. B should be major product. And last one. Last one it is there. Here OH. And same H plus and heat. Now you already know what is the reaction here. All are which one? Ma? Alcohols. What they have given condition? Acidic medium and also heating. You know that acidic medium, heating, and alcohol. Which reaction? Elimination reaction. You know that in this alcohols converted into alkene. We have already discussed it in the PU part. The conversion of alcohols into alkene, the intermediate during this reaction is carbocation. Clear? Because they have mentioned which one? All should be major products. Now you know that here elimination reaction takes place. Elimination means which elimination? Beta elimination always. This is alpha carbon. This is which carbon? Beta carbon. Alpha carbon, attached carbon we will call as a beta carbon. Here also there is a beta carbon. Here 1 hydrogen will be there, and here there will be a 3 hydrogens are there, and here elimination reaction can take place. Here also elimination reaction can take place. Which elimination takes place? You know that elimination follows the Sage-Joff rule. More substituted alkenes are the major products. So remove the hydrogen from here, you will get the more substituted alkenes. A double bond will come here, and there will be a CH3. That is the product. Clear? Ma? Coming to the second one, and in this case you know that first of all here also elimination is there, but rearrangement takes place here. See why? You know that, and oxygen it accepts the always proton because it is electron deficient and it is electron rich. Electron rich gives the electrons to electron deficient and make a bond. Then what will happen, you see, and you will get the compound is there will be a CH3 and OH and H, and oxygen is losing electron. Losing electron means which charge acquires? Positive charge. You know that oxygen having the positive charge is unstable, so that's why one of the bond will break here and this carbon gets the positive charge, oxygen gets the negative charge. You know that. And here this carbon having which charge? Positive charge. And oxygen is gaining electrons. Gaining electron means oxygen acquires which charge? Negative charge. Already oxygen is having positive and negative charges are neutralized, so you will get the minus H2O here. Water molecule will be removed. Now you see which carbocation it is? Secondary carbocation. I already mentioned, whenever carbocation is intermediate in the reaction, then there is a chance of rearrangement. Clear ma? So it is a secondary carbocation, then there is a chance to form tertiary carbocation here, then automatically rearrangement takes place. Clear? See now, and if there is a no chance, if hydrogen is here, if hydrogen involved in the rearrangement, you will get the positive charge here. Same, it is also secondary, it is also secondary, so this hydrogen will not involved in the rearrangement. Now this beta carbon, see here positive charge, and one of this methyl group along with its bond electrons and attack here. You already know all this is. So now what you will get? This CH3 is gaining electron, so that's why CH3 is with charge? Negative charge. Carbon is here with charge? Positive and negative, there will be a bond that I will write here. There will be a bond, and here there is a CH3, and here CH3 is negative charge, acquires negative charge, then this carbon is acquires positive charge. And this is which carbocation? Secondary. But this is which carbocation? Tertiary. Which is more stable? Tertiary is more stable, so that's why rearrangement has been taken place here. Clear? So now elimination reaction. Elimination reaction means what it is? Beta hydrogen should be removed, and we know that this is alpha carbon, this is a beta carbon, and this is also beta carbon, and here you know there is a one hydrogen, here there are two hydrogens. If I remove hydrogen from here, you will get the highly substituted alkene, shades of product, major product you will get. So these bond electrons will come here to neutralize the charge, then you will get the compound is what? You will get the compound here and double bond, and there will be a CH3, that is highly substituted alkene. This is the major product for the second one. Clear ma? Same for the third one. You see third one, what happened? You know, here this is OH, you know, elimination, beta hydrogen is present here, this is alpha, this is beta, this is also beta, this is also beta, all are having beta hydrogens, but removal of hydrogen from here, you will get highly substituted alkene, that is a major product, you know, shades of rule. Then what you will get? You see, you will get the compound is there will be a double bond and hydrogen here, and OH, water will be removed. Then what the product you will get? This is the product. This is the which one? Major product. Clear? Now they are asking, what they are asking here, total number of alpha hydrogens in ABC, means hyperconjugation. Clear ma? You know that this is double bonded carbon, and this carbons we will call as a alpha carbons. Alpha carbons hydrogens we will call as a alpha hydrogens. Clear ma? This is CH3, you know, this I have written means it is a CH3. This is also which one ma? CH3, and here CH3. How many hydrogens are there here? 3 and 3, total how many? 9 hydrogens are there, 9 alpha hydrogens. Here you see, here 3 and here 3, total how many? 6, but here also there are 2 hydrogens are present. This is hydrogen and here hydrogen. This is also called as a alpha hydrogens. 3 plus 3, 6 plus 4, 10. So second case you will get the 10 alpha hydrogens. Now here you see, this is CH3, and here also CH3, this is CH2, H and H, and here also H and H. Total how many? Here 6 plus 4, 10. So total how many? 10 plus 10, 20, 20 plus 9. Total how many ma? 29. That is your answer. Option 4 is the correct. Next one. See the question number 31. Direct question this is. You need not to spend much time on this one. See, you know, tertiary butyl bromide and H2O, then you got here bromides are converted into alcohols. Tertiary butyl bromide is converted into tertiary butyl alcohol with the water. What is the reaction they are asking? You already know it is a nucleophilic substitution reaction. Clear ma? And 32, question number 32. See that one, question number 32. We have already discussed this question in alcohol, phenols and ethers. Among the following, the one that gives positive iodoform upon reaction with iodine and NaOH. We have already discussed this. Clear ma? What is the iodoform reaction? You know that iodoform reaction. According to the iodoform reaction means the alcohol, all options they have given, you see alcohols only. Means to give the iodoform test, the alcohol must have CH3CHOH group. This group if the alcohol has, then that alcohol gives the iodoform test. This is actually test, iodoform test. Clear ma? So options they have given, you see. What is the first option they have given? The first one is C6H5. This is C6H5 CH2 CH2OH. Will it give the iodoform? This one will it react with the sodium and NaOH? Means sodium and NaOH means what it is? Iodoform reaction. Will it give? No. Why? Because you see in this one CH, here CHOH is there. Shall I write this is CHOH, but here which group should be there? CH3, but here which one is there? CH2. So this will not give the iodoform test. Clear? In the same way, second one also. Second option you see CH3 and here CH3. Clear ma? CH2OH. Will it give the iodoform test here? Yellow precipitate will it give? No, it won't give. Why? Because CHOH is there, but here which group should be present? CH3, so it won't give. Next one. Next one is pH, CHOH and CH3. Will it give the iodoform test? Will it react with iodine and NaOH? Yes. Why? Because you see CHOH, what is should be there? CH3. This group is present here. So that's why it gives the iodoform test. Clear ma? So I have already mentioned what is the iodoform test and what are the products formed. We have already discussed it in the PU part in alcohol, phenols and ethers. Clear? So now another one. This is option what it is here? Option 3 is the correct one. Fourth one also this group is not present. So that's why, and option 3 is the correct one. Now 33. Coming to the question number 33. We have already discussed this is in alcohol, phenols and ethers. So I am skipping that question and you already know the answer for that. Clear? Next one, 34. Question number 34. This is important. Clear? So the following compound on hydrolysis in aqueous acetone will give. Clear ma? What is the compound they have given is, this is the compound. OCH3. Clear ma? And there will be a HCH3, CH3Cl and here CH3 and there will be a bond NO2. This is the question. Clear? And on hydrolysis means you have to do the hydrolysis. This is H2O. Clear ma? You can write it is H2O. Now what is the product you will get it? Three options they have given here. KLM, like this big products they have given. So what is the product actually you will get it here? They have not mentioned here whether the reaction follows SN1 or SN2. Clear? So that's why we have to take the two possibilities also. Clear? So first of all, you know that it is alkyl halides and we are using here nucleophile. Assume suppose it is, because it is a secondary alkyl halide. It is a which alkyl halide? Secondary, because you know that carbon attached here, chlorine is attached to CH group, so that's why it is a secondary. Clear ma? Now secondary means secondary alkyl halide can show the SN1 mechanism and also SN2 mechanism. If it is showing suppose SN2, if it is follows SN2 mechanism, then what happened here? Chlorine will be replaced by the OH, one H, you know, H and OH. What will happen here? HCl will be removed. OH attack takes place from which side? Back side actually. Clear ma? So now what you will get the product is this is. one product directly chlorine. You know that here bulkiness is there, so that's why you know this is very big bulkier group, and here also it is a very big bulkier group, so that's why there is no chance of SN2 mechanism here. That first we have to remember. Clear? So because of, you know, nucleophile should attack nucleophile OH is there here, OH minus should attack from the which side? Back side. To attack from the back side, the group should be less bulkier, but here groups are very bigger, very bulkier here, so that's why nucleophile cannot attack the chlorine attached carbon from the back side, so that's why there is no SN2 mechanism here. It follows which one? SN1 mechanism only. SN1 mechanism means, you know that first of all directly chlorine will be replaced by which one here? OH, H and OH. What will happen, ma? This is, then what the product you will get? You will get the product is simple and OCH3, and here there will be a CH3H, and here there will be a CH3. Instead of chlorine, what is there, ma? OH, and because you know, and next one is CH3, and you will get the compound is NO2. This is one of the product. But you know that when the reaction follows SN1 mechanism, what is the intermediate? Carbocation is the intermediate. Carbocation, you know, this is the Cl is there. Clear, ma? So which, if it is following which mechanism? SN1 mechanism. Whenever SN1 mechanism it follows, and which one is the intermediate here? Carbocation is the intermediate. Shall I write again here? I will write in this same reaction in this way. So OCH3, and you know this is CH3 and H and CH3. If the Cl removes, this is the carbocation, then you will get the CH3H, then you will get the compound is here NO2. But you know that whenever is carbocation intermediate in the SN1 mechanism, then there is a chance of which one? Rearrangement. Rearrangement means here this H is there and here also another H. Which H will involved in the rearrangement? That you have to identify. Suppose if this hydrogen involved in the rearrangement, this group will be hydrogen as a H minus and attack on the H plus, then carbocation where you will get? You will get the carbocation here. Now this carbocation, whether it is stable or unstable, you have to determine. If it is stable, that one only will form. You see here benzene ring. Here benzene ring is there, electron donating groups. You know that electron donating groups increases the stability of carbocation. So this carbocation is most stable. Clear? This is one. Suppose this hydrogen is involved in the rearrangement, then where the carbocation will form? Here. This carbocation, is it stable or unstable? Unstable. Why? Because here which one is there? NO2. NO2 is electron withdrawing group. Electron withdrawing group means it withdraw the electron from benzene. Benzene withdraw the electron from this carbon. This carbon positive charge increases. If charge increases, stability decreases. So if this carbocation is unstable, so it won't form. Which one will form? This carbocation. That is the reason here. So what you have to write here, and here hydrogen is there and here hydrogen there. Which hydrogen involved in the rearrangement? This hydrogen, and this will go here along with bond electrons, and the positive charge will come here, and that positive charge is stabilized by the benzene ring and also electron donating groups. Clear, ma? So that's why what the product you will get here? You will get the product is OCH3, and here there will be a positive charge and CH3, and here CH3, H is shifted from here to here, then H, and you will get the CH3H, and it is there, you know, NO2. Just reason you have to think here. So which hydrogen involved in the rearrangement? Which after rearrangement, which carbocation formed, and that carbocation must be stabilized by the resonance effect here. And it is, this carbocation is most stabilized by this group if carbocation forms here, and that carbocation is destabilized by this group. So that's why carbocation formation takes place in this position. Now what will happen here? OH minus attack takes place, positive and negative. What you will get? Bond, and then you will get the compound is here. There will be a OCH3, and here CH3, OH will be formed here, and there will be a CH3 and H, and here there is a CH3 and H, and you will get the compound is here NO2. So we are getting this product, and this is 1 and this is 2. So you are getting both the 1 and 2 products. So your option 1 is the correct. See the now question number 35. Which of the following reaction is not possible? Clear ma? First one, ROH NABR, you will get the RBR and NaOH. First reaction, you see what they have given, ROH plus NABR. Will the reaction takes place? No, it won't take place. Why? Because you see, and what is the reaction? If the reaction takes place, NaOH will be removed and you will get the RBR plus NaOH. You know that NaOH is very strong base. Here it is a strong base means, and it can also act as a strong nucleophile. And you know Na plus and O minus, it is a strong nucleophile. Here which one is there? Alkyl bromide. If strong nucleophile is there, then again it attack on the carbon and bromine will be removed, NABR will be formed, ROH again will get. It means the reaction when it takes place, again it takes place to the backward direction. Clear ma? So that's why. And whenever the base is strong in the product, and again it will react with the product and gives the again reactants. So that's why this reaction will not take place easily. The base which is formed here should be weak base than the Br minus. Clear ma? That is your option is option 1. Clear? Next one. Coming to the question number 36. Clear? In the 36, same question we have already discussed. So first one, they have given here bridged bromine atoms is there here, Br, and the next one is, this is bromine atom is coming here, and the next one is allylic bromide they have given. This is allylic bromide. Clear? 3 options they have given. SN1 reactivity means how they react, which one is involved in the SN1 mechanism very fast. And you already know that the reactivity of the SN1 reaction depends upon the stability of carbocation. We have already discussed. Clear? And you know that if this bromine moves from this, and if the bond break, then bromine will remove, and then here carbon gets which charge? Positive, and bromine gets negative charge. Here which carbocation? Allylic carbocation. Allylic carbocation means you know that it is a positive charge, double bond separated by which bond? Single bond. Then it is in conjugation. When it is in conjugation, it involved in the resonance. When they are involved in the resonance, that carbocation will get most stable. Clear ma? This is most stable. Why? The carbocation is most stable here. Why most stable? It involved in the resonance. Clear ma? Coming to here, and in the last class, in the last video, we have already discussed, and if you remove the bromine here, this carbon get the positive charge and this bromine get the negative charge. But here which carbon here? Bridged carbon. You know that bridged carbocation never forms. In the last video I have already mentioned why it won't form. Clear? So this won't be in carbocation is very unstable, so that's why, and it will not involved in the SN1 reaction very fast. Next one, what it is? Bromine removes here, then which carbocation you will get? Secondary carbocation. You know that first which carbocation is most stable? Allylic carbocation, then tertiary, then the secondary. So that's why third one and will involve in the SN1 reaction very fast, and after then the second one, and last one is least reactive is first one. Clear ma? So your option is option 2 is the correct one. Next one, coming to the question number 37. Which of the following compounds will show NGP? NGP I already mentioned in the last class. What is the NGP? Neighboring group participation. Clear ma? Neighboring group participation. So neighboring group participation, what is the main conditions? The alkyl halides, whatever it may be, and alkyl halides or alcohol, whatever it may be, and that compound should have the internal nucleophile. And you know that internal nucleophile and the leaving group should be in which direction? Opposite direction. See the now option 1. What is the option 1 they have given here is S, pH, and H here, and H and Cl. Clear ma? See now here It is a sulfur. Sulfur is having what it is? Lone pair of electrons. Lone pair of electrons means it can act as a nucleophile. And here leaving group. And yes, sulfur is upward and chlorine is downward. Both are in which direction? Opposite direction. Whenever they are in opposite direction, they participate in the neighboring group. Clear ma? So neighboring group will be participated and sulfur will attack here and chlorine will be removed. Clear ma? So option 1. And second one you see option 2. So it is participated in the neighboring group participation or not? Yes, NGP. Clear ma? So this compound involves in the NGP. Second one you see same compound H, SPH and H and chlorine. You see this is neighboring group and leaving group. Both are in which position? Same position. So there is no NGP. Next one. And third one and fourth one, there is no internal nucleophile. So there is no chance of NGP. So that's why your option 1 is the correct one. Clear? Coming to the 38. Clear? So consider the reaction of HI of the following, which forms diiodide on reaction with HI. Diiodide. Clear ma? You know that this is a ether, cyclic ether. They have given which one ma here? Cyclic ether. So when you know that whenever ethers treated with the HI, excess amount of the HI, you will get the iodides are the products. Clear ma? Now if I treat this one with the HI, clear ma, excess amount, and you know that 2 iodines will be added here and O and H will be removed as a H2O. Shall I write ma? This is simple. I will write in this way. Clear ma? This is treated with which one here? HI. HI means first of all, what happened here? One break, because both the bonds are similar. Anyone, this bond or this bond can be broken here. So that's why when this bond breaks, hydrogen will be added to which one ma? Hydrogen will be added to oxygen. This is OH, and here there will be a iodine. H will be added to the oxygen and I will be added to this carbon. This is, but we have taken what it is? Excess amount. Excess amount means iodide should be the product, and HOH and H will be removed as a water. Iodine will be added here. Then you will get the compound is, clear ma? This is iodine and this is iodine. Diiodide compounds formed or not. First one gives, whether the second one gives or not, you have to check it. Check it whether it give or not. HI. So now which bond breaks here? And here both bonds are similar, so that's why any bond can break here. But here you see, and here this bond and this bond both are different. You know that this oxygen is having lone pair of electrons, and here which bond is that? Double bond, and they are in conjugation involved in the which one? Resonance. Resonance means this bond is a which bond? Not a single bond, it is a partial double bond. It is a double bond and it is a single bond. Which bond can easily break? Single bond can easily break. So that's why you should not break this bond, A bond and B bond. You should not break the A bond. You have to break the which bond here? B bond. Clear ma? Then what happen? You see, you will get that to the O hydrogen you have to add. Then you will get the compound is OH, and here you will get iodine. Next, because we treated with the HI, will this OH and H will be removed like in this case? No, won't happen. Why? Because this bond is not a single bond, because it involved in the resonance. So that's why O and H will not be removed as a water. You will get only no reaction. Next one. So you will get only which iodide here? Mono iodide. So that's why your option is option 3. Only one will give the diiodide. Okay, sir. 39. Coming to the question number 39. Clear ma? You already know this type of reactions. I said so much important and we have discussed it so many times, but as this reaction is very important, so that's why I am discussing here again and again. Clear? CH3Br CH3. Clear ma? So what they have mentioned here is, on the arrow they have given ethyl alcohol, and they only mentioned here SN1 reaction. What is the product? A. What is the product? A. You already know that. Here which reaction it is? SN1 reaction they have mentioned. nucleophilic, unimolecular nucleophilic substitution reaction. You know that. What is the intermediate in the SN1 reaction? In the SN1 reaction, carbocation is the intermediate. SN1 reaction involves how many steps? 2 steps. In the first step, carbocation formation takes place. In the second step, nucleophile attack takes place on the carbocation. So SN1 they have given very clearly. So that's why first step, what is the first step? Formation of carbocation. Bromine will be removed. Carbon and bromine, which one is more electronegative? Bromine. Bromine is more electronegative means this bond electrons will be taken by bromine. Bromine is gaining electron. Gaining electron means negative charge. Carbon gets the positive charge. So you will get CH, CH3 and here CH3, CH3. You will get which charge here? Positive charge. Which ion is removed here? Br minus ion. This is carbocation. Which carbocation this is? It is a tertiary carbocation because that positive charge attached carbon is not having any hydrogens. So it is a tertiary carbocation. Clear ma? Now I already mentioned, whenever there is a carbocation intermediate, if there is a chance, then there is a chance of rearrangement. Clear ma? Because tertiary carbocation is most stable. Is there any chance to get the most stable carbocation than the tertiary carbocation? Yes, there is, because you know that here hydrogen. Clear ma? If hydrogen is there, you know that this hydrogen along with its bond electrons. Along with its bond electrons means hydrogen gets which charge? A negative charge. And a negative charge here which charge? Positive. So that's why rearrangement takes place. When the rearrangement takes place, you know that H minus means this carbon gets which charge? Positive. So you will get pH and here CH3 and here which charge? Positive charge and CH3 and hydrogen negative charge, carbon positive charge. There will be a bond between the carbon and hydrogen. Clear ma? Previous tertiary carbocation. Now it is which carbocation? This is also tertiary. Then what is the necessary for the rearrangement to take place here? Rearrangement when it takes place? When you will get the more stable carbocation than the tertiary, then only rearrangement takes place. But you know this is a tertiary carbocation, but here which one is that? pH. pH means what it is ma? Benzene ring. This is a which ring ma? Benzene ring. pH means this is a benzene ring. So benzene ring is there. You know that here positive charge, double bond are separated by single bond. It is a conjugation. It is a conjugation means it involved in the which one? Resonance. Clear ma? So this positive charge carbocation is tertiary carbocation, stable and also stabilized by which one here? Resonance. So that's why this tertiary carbocation is most stable than the first tertiary carbocation. Clear ma? So that's why rearrangement takes place here. Now it is a carbocation. Then what they have given nucleophile here? Ethanol. Ethanol means you already know that. And O minus and H plus. Here positive charge, negative charge. There will be a bond. Then what the compound you will get? You see, you will get the compound is, clear ma? So what is the compound? And here there is a pH and CH3 and O ethyl group. And here CH3, CH3H. This is the major product. This is the which product ma? Major product. And suppose if ethyl OET will attack here on this carbocation, that is the minor product. This is minor product. pH and CH3H and CCH3CH3 and OET. This is the minor product. And this is which one? Major product. See next question. This is the question they have given. HCH3OH ethyl SOCl2. You know that SOCl2 means chlorine OH will be replaced and by the chlorine Cl will get. But very important, this they have not given. You see SOCl2 means it follows SN1 reaction. I have already mentioned. SOCl2 and pyridine means it is a SN2. It follows, this reaction follows which one? SN2. SN2 means nucleophile attack takes place from which side? Back side. So what is the product you will get? But in the SN1 reaction, the nucleophile attack will take place from the front side or from the back side. Which one is the major here means you will get, you will not change here CH3H ethyl and OH. This is because it follows which mechanism? SN1. SN1 means where the nucleophile is there and from the chlorine will be added on the same position. If they give question like this, pyridine if they give, it follows which reaction? SN2. Actually we will call it as internal nucleophilic substitution reaction. SNI we will discuss, but for competitive you identify in this way. And it is a SN2. SN2 means chlorine will attack takes place from which side? Back side. Then what the product you will get? You will get CH3. Back side means here chlorine, here H and here Et. So that's why this is your product. So option 1 is the correct one.